Hi students, let's look at this question here, which is on Maclaurin series. This question was taken from 2020 MI paper 1 question 6. Let's see how I can do this proficiently. You're given that y is equals to root ex cosine x, and you were told to show this. I think we have done this kind of question multiple times. I would suggest square both sides. Don't do direct differentiation, because implicit differentiation will be much easier. So this case here, what we get is y equals to root ex cosine x here. What we're going to do is just square both sides here. Okay, square both sides. Yeah, it will be much better in the sense that we get y square equals to ex cosine x. Alright, so what we're going to do here is actually just do, this is u and this is v. I'm going to just use implicit differentiation, so differentiate with respect to x here. This will be 2y dy dx equals to, keep the one on the left, differentiate the one on the right, sine x, plus differentiate the one on the right. Keep the one on the right and differentiate the one on the x left. So this is the case there. Now, there you go. You see, we got this expression here. So what we need now is actually look at this one here. This is ex. So let me just u v prime plus v u prime here. Okay. So we could actually see that this is our this is this expression here. So I'm gonna rewrite this out. This will be 2y dy dx, so minus ex sine x plus y square. Okay, so there you go. So this is the first part. I think the first part is pretty okay. Use implicit. I would suggest using implicit. Of course, you can get it by using direct differentiation, but when you're doing H2 math, please remember it's good that your default differentiation technique be implicit. Okay, it will really elevate a lot of your pain point. Let's look at part 2. By further differentiation, use the result in part 1. Find the series up to including x squared, meaning we need to find all the way to d square y dx square. Okay, so means we just differentiate once more. So this part 2 here, differentiate 1 with respect to x. This will be, keep the one on the right, dy, d square y dx square, plus dy dx, keep the one on the right, differentiate the one on the left, will be 2 dy dx. Okay, so keep the one left, differentiate right, keep then 2y dy dx minus ex cosine x plus sine x ex. Alright, so I think this is pretty okay. uv prime plus v u prime. Then this case here on the one on the right, u and v, uv prime plus vu prime. Okay, that's about it. What we're going to do next is essentially, you don't need to simplify them, because what we need is just to hunt for all the different terms, right? So when x is 0, what we have is y is equals to cosine 0 is 1, e0 is 1, so y is 1. Okay, then we need to find dy dx here, so just key this in. Y is 1, so when you find your y is 1, so this case is 2 1 dy dx is what we need to find. Y is 1, 0 sine 0 is 0, so dy dx is just half. Okay, so that's how we do it. This is dy dx equals to half. So this one don't really need to same thing, don't need to simplify, because we just need to find what are the values there. So y is 1, so this would just be 2 times 1 d square y dx square. I like to find the one dy dx would just be half times 2 times half equals to 2y times half minus 2y, which is 1, right, times half. E0 is 1, cosine 1 is 1, sine 0 is 0, so this will be 0 here. Okay, so this part will be 0, then this will be d square y dx square would just be, this is 0 minus half, negative 1/4. So this case here, what I'll get is actually d square y dx square is actually just minus 1/4. Okay, so this case here, y, the Maclaurin series of y will be, just bring out Maclaurin series here. Let's look at the last part. Using the standard series from list of MF26, expand this as far as the term x squared and verify that the same result in part 2. There's a typo here. Okay, so we need to show this. Okay, so let's see how we can do that. First thing is we just use standard series as usual, part 3. So this is square root ex cosine x, right? Alright. I would suggest using ex over 2, and after it, this is cosine x half. Just split this up. Then we bring out the cosine x formula and the ex formula here. Okay, the MF26 here. Let's bring out MF26. There you go. So in the on the second page, we will get ex. So we're going to sub x as half and cosine as half as x as well. So this case here, bring out the formula for exponent, bring out the formula for cosine, right? So these two here pretty okay. I think we're gonna just do this part here. Ex would just be 1 plus x over 2, because we just need to all the way to the second square, so we just stop at square there, plus dot dot dot. Then cosine x, same thing, we just need to square until square. This is 1 minus half x squared plus dot dot dot. This case here, what we get is 1 plus half x plus 1 over 8x squared plus dot dot dot. The one behind here, let me just put a curly bracket here, equal approximate. So this case here, this we're going to use power series. So power series would be here. What we get is 1 plus half minus half x squared. Okay, just stop at the x squared because we only need to x squared. So I'm going to stop there. This case here will be 1 plus half x plus 1 over 8x squared. And this will be 1 minus 1/4 x squared. Okay, so then just expand this case here, will be 1 minus 1. So I'm just gonna expand it. Then this will be minus 1/4 x squared here. Alright, let's see what we get. This will just be 1 plus half x. So 1 over 8 minus 1/4 will be 1 minus 1 over 8 squared. Okay, so part 3 is just to show that you can also expand it using standard series. Okay, that's about it. I think it's pretty okay. Any question or comments, please let us know, and I'll see you in the next question.